Well, we're still in Chapter 1, and our book is still the same. We're in Section 4-1, Plurality with Elimination. This is a method to do an instant runoff or a recount in case somebody drops out of the election, isn't qualified, or some reason like that. When there's 3 or more candidates, it's often no candidates that gets a majority. And I touch the screen. Typically, the candidate or candidates with the fewest first-place votes are eliminated, and a runoff election is held. Since runoff elections are expensive to everybody concerned, this might be inefficient, so we need a better method. So the better method is I just choose between them, and then we just walk away, and that'd be fine. No? A much more efficient way is to implement some process without needing a separate runoff election. And of course, if you're going to have such a process, you have to have it in place before the election occurs. Otherwise, that wouldn't be fair anyway. So we're going to have an instant runoff voting. Other names have been used in the past for this method, including plurality with elimination and the Hare method. Never heard of Hare method, but that's okay. We can call the plurality with elimination method the most descriptive of the 3 names. Round 1. Count the first place votes for each candidate. Now, we don't have any first place votes for each candidate, right? Because we don't normally do an election that with first, second, or third places. But all right, so this is what we're going to do. Count the first place votes for each candidate, just as you would in another method. If a candidate has the majority of the first place votes, then the candidate's the winner. Otherwise, eliminate the candidate or candidates if there's a tie with the fewest first class votes, and then redo the election. 2. Cross out the names of the candidates eliminated from the preference schedule. Remember, when he's eliminated from the preference schedule, in each column the candidate below the spot moves up. If a candidate has a majority of first place votes, then declare that candidate the winner. If not, eliminate the next candidate with the fewest votes and do it again. Repeat the process until you have a winner. And in so doing, we'll do the math election again, and we already had 3 people win. We'll have the 4th person win this time, I can just imagine. So here it comes, the math club election, table 1-1. And so here's our people, and A has 14 votes, and C has 11, D has 8, B has 4, but none of them have a majority. So we're going to eliminate the person with the least first place votes, which would be B. Okay, so we get rid of B. Well, he looks pretty ugly anyway, so that's probably why we got rid of him, right? And then now the first place votes end up in that category, 14, 11, 12. And then we get rid of C, and D wins, because C had the least number of first class votes, and then C won. And we'd have to go back to the slide where everybody was being shown. Come on, I can't get back. Bet you I can. Okay, so when I eliminated B, then D ended up with B's votes. And then I'd eliminate C. B was already gone, so D ended up with all the votes except the 14 that A had, and that's why D won. So as I eliminate the candidate, when I eliminate B, D gets 12 votes. When I eliminate C, B's already been eliminated. D gets all the rest of the votes, and A loses the election. Isn't that lovely? Such a lovely method. There's a problem with this, and it's going to be a subtle demonstration in the next example. 3 cities for the Olympics: Athens, Barcelona in Spain, and Calgary, probably in Canada, are going for the Olympics. The final decision will be made by secret vote of 27 members. So here's a straw vote, and we find that A has the most first place votes, but doesn't have a majority. Now, based on the results of the straw poll, Calgary is going to win the election. In the first round, Athens has 11 votes, and Barcelona has 8, Calgary 10. Barcelona is eliminated. The second round, the 8 votes go to Calgary with 18 votes. In the second round, Calgary wins. Okay, well, we can handle that. Although the results of the straw polls are supposed to be secret, the word gets out that it looks like Calgary is going to have the Olympics. Since everybody loves a winner, the 4 delegates represented by the last column decide to as a block to switch their vote to Calgary first and Athens second. If they do this, will Calgary win? No. The results of the official voting changes between the straw poll and whatever, and what happens is that somebody else wins. So now Calgary gets 14 votes, not enough. Athens gets eliminated. Now the Barcelona ends up with 15 votes, the majority, and they will win. So if I can manipulate the election because I know the results, and I know I'm going to use that method, then I can have a difference. When we apply this method to table 1-10, Athens gets eliminated in the first round. 7 votes originally going to Athens go to Barcelona, and in the second round, and Barcelona wins. Now, they're not going to have the next Summer Olympics because we make those decisions 12 years in advance. So, but other than that minor problem, how could this happen? How could Calgary lose an election if it was winning in the straw poll, got more first-class votes, but still lost? And you think it might be rigged. Double-checking figures make it clear that everything was on the up and up. Calgary is simply the victim of a quirk in the system. All right. So North Korea lobs a couple nuclear weapons over here, wipes out LA and San Francisco. Just a quirk in the system. Not a problem, right? Yeah. Monotonicity. And the monotonicity criteria. If a candidate X is the winner of an election, in a re-election, the only changes on the ballots are made in favor of X, then X should remain the winner of the election. So what happened in the last example violates this criteria. If I'm going to win the election and I get more votes than they open the absentee ballots and I still got more votes, then I should still win. So it violates monotonicity and Condorcet. All right, just what we need. So where do we use this particular message? Okay, well, we use it in the Olympic Games. We use it in San Francisco in their mayoral elections in 2002, and 2 other places. Ferndale, Michigan, never heard of it. Australia has used it to elect members of the House of Representatives. Well, they don't have much to do in Australia anyway, so they can have a complicated voting system. Am I going fast enough? Okay, now they just are so wonderful. They just, yeah, exactly. Okay, still our book. Pairwise Comparison Method. Okay, now we're going to pair people off one at a time and count how many times they win the pairing. And it's going to be a pain in the backside, but other than that, everything will be fine. So every candidate is matched head-to-head against every other candidate. Each of these head-to-head matches is called a pairwise comparison. Every time you win, you get one vote. And you count up all the votes and see who wins. If there's a tie, then the comparison ends in a tie. If two candidates splits the vote equally, then that's a tie, and we don't count that vote. The winner of a comparison gets one vote. The loser gets none. In case of a tie, they get a half a vote. Okay. That sounds like fun. The winner of the election is the candidate with the most points. Overall points ties are common under this method. The tie is broken using a predetermined tie breaking procedure, like standing on a cliff and who jumps off first, something like that. Now we're going to do the math election with a pairwise comparison. And we'll start by A versus B. That seems like a good idea. So we look at A versus B. So A gets 14, B gets 10, B gets 8, B gets 4, B gets 1. So we'd have to write that down someplace so we know if they did that. And then, so A gets 14 votes, B gets 23. Okay, and then we got to do it again. We're going to compare C versus D. Looks like C gets 24 for C. No, 25 for C. 25 for C, and only 12 for D. Okay. It looks like we're only giving one lousy vote, one lousy point for being ahead. Yeah, that's what it looks like. Alright, so A to B, B gets a point. A to C, C gets a point. A to D, D gets a point, and so on. And when we get done, C wins the election. It has 3 points. The final total produces 0 points for A, 2 for B, 3 for C, and 1 for D. Can this actually be true? The winner of the election under this method is Carmen, and she never won before. So isn't that great? And this satisfies all 3 of the fairness criteria discussed so far in the chapter. I guess so. So far, the method of pairwise comparison looks to be our best method. At least it satisfies some of our ideas of fairness. Unfortunately, the method does violate the 4th fairness criteria. All right. So we have the NFL draft. We'll be getting the number 1 pick. After narrowing the candidates to 5 people, went to provide the coaches and the team look it over. They vote on it. They turn in their preferences. They have their preference card. They do piecewise comparison, and they end up voting on something. Finally, they total the votes, and 3 points for A, 2.5 for B, 2 for C, 1.5 for D, 1 for E. Looks like Alan is the lucky man who makes the $1 million plays. The interesting twist to the story surfaces when it's discovered right before the actual draft. that Costantino has accepted a scholarship to med school and will not be playing football. Since he wasn't the top choice, this fact shouldn't matter, right? But in fact it does. And so they go back and they do it again with Costantino not a candidate. And we do it again, do a piecewise comparison, and we find out that Bayer is the #1 pick, not Allen. So now what do we do now? How can the presence or absence of somebody who isn't going to win going to change the decision relative to the pool? I mean, who was the best guy to begin with? It would seem to me like, well, they're all the same, right? One basketball is the same player. Yeah, right. It's the same as another basketball player. It really doesn't matter. Is this football? Yeah, any basketball player on a football team, you know, just as good as any other basketball player on the football team. Doesn't really matter. The strange happening in example 1-2 helps to illustrate the fairness criteria called independence of irrelative alternatives criteria. This is why you get a second opinion on your test, because clearly your first choice probably would not be that one, and that might be the right answer. But at least it's the longest criteria. So if there's some irrelevance come in and it comes out, irrelevance, the independence of irrelevant alternative criteria. If a candidate X is a winner of an election, and in a recount, one of the non-winning candidates withdraws or disqualified, then X should still be the winner. I would hope so. That's why I drink Coke Zero, because it's obviously the winner. Switch the order of 2 elections. Think of the recount as the original election and the original election as the recount. Under this interpretation, it says that if a candidate X is the winner of election, and in a re-election another candidate that has no chance of winning or irrelevant alternative enters the race, then X should still be the winner. So it shouldn't matter. I'm driving the Daytona 500 and I should be the winner, and some other guy enters the race who drives 100 miles an hour. I should still be the winner. I should not be relevant. How many piecewise comparisons can we have? 5 candidates, we can have 10. 10 candidates, 45. 100 candidates, we can have 4,950 piecewise comparisons. When was the last time you did 4,955 things and didn't make a mistake? Yeah, exactly. So there's plenty of room here. Oh, we have 2 formulas, so we know how many piecewise comparisons there are. Isn't that great? Just what I needed to know. Number of candidates times n-1 divided by 2. The sum of the consecutive integers. Okay, well, remind me to put that on the board if somebody should ask for that on a test sometime. That would be a mistake, probably. But yeah, if I had n candidates, then that A guy would have to be compared against B, C, D, E, F, G, right? But the B guy would only have to be compared against C, D, E, F, and the D guy would just have to be compared against the guys under him, right? So that, and then we divide by 2 because you could have because B compared against A is the same as A compared against B. I hope I mumbled enough there. So now we're going to do a round-robin tournament. Each player plays every other player once. Imagine that you change the schedule for a ping pong tournament. You have 32 players. The tournament organizer agrees to pay $1 per match for running the tournament. You want to know how many matches there are. Okay, well, we do this the same rule. 32 players times 31 divided by 2. That's how many matches there are. We do a double elimination tournament for a math competition at Iowa Western in April, and we expect over 90 teams to show up. So that's is always fair. Oh, well, that's good. One more, or are we done? Is this the sixth guy? No, rankings. All right, last section, rankings. Extended ranking method. Quite often it's important not only to know who wins the election, but also to know who comes in second, third, and so on. We need a voting method to tell us the ranking of the candidates. Okay, well, if you say so. So here we have the math club people, and the most striking thing about table is the wide discrepancy of results. Okay, that's good. So we have extended plurality A1, and vote account B1, and with elimination D1, and piecewise comparison C1. So everybody won, came in first place depending on the method we used, and people came in second, third, and fourth a little more consistently, but not that much more. Okay, so obviously the rankings will depend on what method we're using. All right. Well, it's somewhat frustrating to see this. It's important to keep this in context. You need to have your rule for the election set up before you do the election. Most real elections tend to be more consistent. Recursive ranking method. The idea behind a recursive method is that you start, is similar to a feedback loop. At each step of the process, the output determines the input for the next process. In this case, the election process finds the winner is removed, and then you figure out who the second place guy is. Then you do it over again and over again and over again until you get it right. We apply method X once again to find the winner based on the new preference, and we continue on. So recursive plurality. Here we show a ranking of 4 candidates in Math Club, and A wins, we eliminate A, we figure out who comes in second. So A wins. With A eliminated, it would look like B would win. With B eliminated, A and B both eliminated. It looks like maybe C would win. But what we do is we write that down to see what it looked like. All right, so now B wins. All right, that's fine. And now C wins, and then D would come in last. A, B, C, and D. Recursive plurality with elimination. We need to just look at the difference between those two. The winner at the next step is, in the recursion, is removed from the preference schedule so that we can move on to the next step. All right, so we remove D. No, we remove B because he has the least number of votes. Choose the winner and remove from the table. After several rounds of eliminations, the winner is D. All right, well, that looks like fun. D, C, B, A. It's clear that the last two examples, that other than first place, the recursive ranking method and extended ranking method can produce very different results. Okay, well, that's fine. Oh, done with chapter 1. It's only 9 o'clock. Not even 9 o'clock. Time for homework. Now the plan is to finish chapter 1, start into chapter 4, so that when it's time to do the chapter 4 test a week from today, we have plenty of time to do it. So that's the overall plan. Okay, I'm going to have to start with problem number 21. No, 27. Yeah. problem number 27. Plurality with elimination. This exercise refers to the math department, and okay, so we have 5, 3, 5, 2, 2, 3, and first choice A, C, D, D, B. And second choice B, D, E, C, C, E. And third choice C, B, D, B, B, A. I'm losing my columns. Fourth choice D, C, A, E, A, C, and E, E, B, A, E, D. Okay, so we're figuring out who has the least number of first place votes. A has 8, 5, 4, 3. So B has the least third place votes. So we're going to eliminate B. Okay, now that we have B eliminated, we're going to redraw our table. A, C, D, E, A, D, C, E, C, E, D, A, D, C, E, A, D, C, A, E, E, A, C, D. And we can almost see the votes they had. 5, 3, 5, 2, 2, 3. Okay. And now A has 8, D has 4, E only has 3, so E gets eliminated. Okay, now we're going to draw the table again with E eliminated. A, C, D, A, D, C, C, D, A, D, C, A, D, C, A, C, D. Oh yeah, so A's got 5, 11. Has 11 votes. Well, if A has 11 votes and there's only, A has 11 votes and there's only 9 left over, A is now the winner because he now has a majority. I think. Or do we keep on eliminating? Maybe keep on eliminating. I think that's the case. Who's out? D is out. So D's out. D out, A still wins. Yeah, that's what I thought. A wins. Is that all they want to do? Use the method to determine the winner. Suppose that before the votes are counted, elector C withdraws from the election. Find a new preference schedule for the election without candidate C. Sounds like busy work. Use it to find who wins the election without candidate C. Bummer. Guess I have to do that. So I'm going to rewrite the preference schedule without C. Yeah, bummer. Be better if I was using a spreadsheet, right? Okay, 5, 3, 5, 3, 2, 3. I think I wrote it down wrong, didn't I? Yeah, I got a 2 there instead of a 3. What did I? Yeah, I mean, that was way from the top. All right, so I'm going to do this without C. A, D, D, B. Without C. B, D, E, E. Without C. B, D, B, B, A. E, D, D, A, E, A, C. E, E, B, A, E, D. Okay, now that I've done that, B still has the least first place votes. He goes away. And I rewrite A, D, E. A, D, E. D, no, E, E, D, A, D, E, A, D, A, E, E, A, D. Right, so E, oh, there's a tie. All right, so tie doesn't really matter. I get rid of D. And if I do that, then A's going to win. No, nope, E's going to win. 5, 3, 3. E's going to win when I do that. So when A used to win, when C went away, E wins. E wins. And what violation of the fairness doctrine? Monotonicity. Monotonic, T-O-N-I-C. Because if A won the first time, I should have the other guy winning. And the other thing is this irrelevant thing? Some loser dropped. I think this is the IAA one too. Oh well. Moving on to number 33. A professional surfing association executive committee is having an election to choose a site for the next Quicksilver Extreme Surfing Tournament. They just made this up. The candidates are A, B, C, and D. Isn't that right? The preference schedule is below. All right. Use plurality with elimination to find the winner. All right, so I got 10, 7, 5, 5, 4. I have A, C, B, D, D, B, A, C, B, C, A, D, C, D, A, B, B, C, D, A. C loses. Boom. I'm going to get rid of all the C's. Rewrite my chart. A, B, D, D, B, A, B, A, D, D, A, B, B, D, A. B has 9, D has 12, but no one has a majority yet. And who loses? Bravo loses. Okay, so B goes away. And A ends up with 10, 15 votes. And D ends up with 9, 16 votes. So D is the winner. Find the Condorcet candidate in this election. All right. Does anybody remember what that means? I mean, that was all of Monday, right? That was a long time ago. That's 3 days ago, right? So that means I have to turn back in the book to find out what the Condorcet candidate is. Piecewise comparison with that. If the candidate X is preferred by the winners over the other candidates in a head-to-head comparison, then X should be the winner. Okay, Condorcet candidate. All right. So we're back to the original thing. All right, so A is preferred over B. How many times? 10. 10 times. A is preferred over C. How many times? 10, 17, 17. A is preferred over D. 10, 15, 15 times. A is preferred. We run out of people. Do we run out of people? Yeah, we run out of people. All right. B is preferred over A. 7, 12, 16 times. B is preferred over C. 7, 12, 16 times. B is preferred over D. 10, 15, 19 times. C is preferred over A. 5, 10, 14 times. C is preferred over B. 10, 15, 15 times. C is preferred over D. 5, 15, 20, 24 times. All right. D is preferred over A. 7, 12, 16. D is preferred over B. 7, 12, 12. D is preferred over C. 7, 7. Well, it looks to me like that means that Charlie is the Condorcet candidate. He's preferred over the candidates more than anybody else. The results of A and B imply a violation of which criteria? Okay, well, who won the first guy anyway? D is the winner. And D, it looks like, comes in last place the other way. Which fairness doctrine? Pick a fairness doctrine. It must be that one. Let's see. This is where the class helps out and tells me the answer. Independent of irrelevant alternatives. Nope, not that one. Monotonicity, if candidate X wins the election, and in a re-election, the only... Nope, no, not that one. Condorcet rule. If election candidate is preferred by voters over each of the other candidates here in comparison, he's the winner. Majority criteria. If a candidate has a majority of the first place votes, then that candidate should be the winner. So I think this is the majority criteria. Is probably what I would pick. Okay, that was 33, going to 35. Pairwise comparison. All right. Use the pairwise comparison to find the winner of the election. Okay. So we're looking A versus B. A versus B. So A has 8. No, B has 8. A has 6. B has 5. A has 5. A has 2. It's a tie. So A gets a 1/2 and B gets a 1/2. Okay, now I'm going to look at A versus C. Okay, C gets 8. A gets 6. C gets 5. C gets 5. C's going to win. So C gets 1. Okay. Now we're going to look at A versus D. A versus D. A gets 8. A gets 6. D gets 5. D gets 5. D gets 2. A wins. A gets 1 vote. Okay, then we're going to look at what color do I have left? A versus E. A gets 8. A gets 6. A wins already. Okay, so A gets 1. Okay, now we're going to look at B versus C. B versus C. C gets 8. B gets 6. C gets 5. C gets another 5. C wins. C has 1 vote. I'm going to look at B versus D. B gets 8. D gets 6. D gets 5. D gets another 5. D wins. D gets 1. Then we're going to look at B versus E. B gets 8, E gets 6. E gets 5, E gets another 5. E gets 1 vote. Okay, then we're going to look at BC versus D. And C versus D. C gets 8, D gets 6. C gets 5, D gets 5, D gets 2. Is that a tie? That's a tie. C gets 1/2, D gets 1/2. Okay, and then we're going to look at C versus E. C gets 8, E gets 6. E gets 5, D gets 5. D gets 2. D. I think I did that wrong. I'm going to do that over again. I'm looking at E versus C. C and E. All right, C and E. All right, so 8, 6, 5, 5, 2 goes there. That's a tie again. C gets 1/2, E gets 1/2. Okay, and then we're going to look at D versus E, which is our last one. D versus E. So 8, 6, 5, 5, 2. E, D gets 1. Okay. Now we get to add them up. A has 1/2, 1.5, 2.5. A has 2.5. B. B has 1/2. That's all. B has 1/2. C. 1, 2.5. 3. C has 3. D. 1, 1.5, 2.5. And E has nothing there. 1.5 total. So we're going to declare C the winner by piecewise comparison. Suppose that before the votes are counted, candidate A is declared ineligible. Find the new preference schedule for the election without candidate A. And then do it again. What a pain. Whoever thought? B. All right, so we're going to do it without candidate A. 8, 6, 5, 5, 2. Okay, I got that. C, B, D, E. E, D, B, C. E, C, B, I'm getting rid of A. E, C, D, B. D, C, E, B. D, E, B, C. Okay, so now I'm going to do it all over again. All right, I'm going to go B versus C. C gets 8. Is that a 6?
Yeah.
Yeah, that's a 6. I wrote that too big, didn't I? B versus C. C gets 5. C gets 5. So C gets 1 vote. And then I'm going to look at B versus D. 8 votes there. 6 votes there. 5 votes there. D gets 1 vote. And then I'm going to look at B versus E. 8, 6, 5, 5. E gets 1 vote. B, C, D, E. Okay, so I got them all. Okay, then I'm going to look at how I'm going to look at it. I'm going to cheat. So I'm just going to zoom this to 75%. Yes, I love it already. Okay, so now we're going to look at C versus D. 8, 6, 5, 5, 2, tied. C gets a half, D gets a half. We're going to look at C versus E. 8, 6, 5, 5, 2, we're tied again. C gets a half, E gets a half. And then we only have one more to do, and that's D versus E. 8 for D, 6 for E, 5 for E, 5 there, and 2 for D, so D gets 1 vote. All right, so B, C, D, E. All right, B has nothing, 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 nothing. B has 0 votes. C, 1, 2 votes. D, 1, 2.5 votes. E, nothing, nothing, 1.5 votes. So delta has 1. Did delta win the time before? Yeah, typical. Stupid election anyway. Without a. The result implies a violation of which fairness criteria? Okay, so the first election C won, the second election D won, and well, we'll go with monotonicity. Monotonicity. Because I can spell it, I think. Okay, one more problem and we're done with chapter 1, and then we go to where we have to add and subtract, multiply, and divide again. I don't believe it. How did that happen? 41. Ranking. Okay, just what we need to do. 41. We probably have to rank 7 different ways, and it'll take us until 10 o'clock. I can see it now. No? For the election, blah, 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 X and 33, there it is. Rank the candidates using extended morality method. Using extended rota count method. Using extended plurality with elimination method. Rank the candidates using extended piecewise comparison method. Yes, this is going to take all night. I can see it now. Well, at least I didn't do it before class. Okay. So A. Who comes in first place? Who has the most first place votes? A. So A comes in first. When A is gone, who has the most first place votes? C. C? D? No, when A's gone, C would. C would have 15. Yeah, C would be next. All right, C would be next. Okay, with A and C both gone, then B would be next, and that makes D last. All right, well that was reasonable. Was that reasonable? All right. Now, Broda count method. Broda count method means we put a point value on everybody and add it up. Okay. So that means I'm going to have to actually write the chart. 5, 10, 10. A, C, B, D. 7. D, B, A, C. 8. B, no, it's a 5. 5. B, C, A, D. Another 5. C, D, A, B. A 4, B, C, D, A. Okay. And these guys get 1 point, 2 points, 3 points, 4 points. Okay. So A is going to have 40 plus 14 plus 10 plus 10 plus 4. And B is going to get 20 plus 21 plus 20 plus 5 plus 16. And C is going to get 30 plus 7 plus 15 plus 20 plus 12. And D is going to get 10 plus 28 plus 5 plus 15 plus 8. This is a good time to have my calculator out. Before now, pretty irrelevant. Well, I don't know. 40, 50, 60, 70, 78. 20, 40, 60, 70, 20, 40, 60, 72. 30, 40, 50, 60, 70.
82.
Is it 82? 30, 40, 50, 60, 70, 80, 84. 10, 30, 40, doesn't matter. 84 has it. So C is the first place guy. All right, now I got to redo the chart without C. Yeah, I know. Pain in the butt. See if I can even get the right problem. Okay, 10, 7, 5, 5, 4. And I'm doing it without C. A, B, D, D, B, A, B, A, D, D, A, B, D, D, A. And I'm assigning 1 point, 2 points, and 3 points. Okay, so the A guy, 30, 7, 10, 10, 4. The B guy, 20, 14, 15, 5, 12. The D guy, 10, 21, 5, 15, 8. 30, 40, 50, 61, 20, 30, 40, 50, 66, 10, 30, 40, 59. Okay, so B came in second. Okay, now that B came in second, we're writing it again without B. Okay, so I got 10 AD, 7 DA, 5 AD, 5 DA, 4 DA. Well, I have 15 up there for A on the top, and I've got 16 up there for D on the top. So D is going to come in next. I really don't have to do anything, and A is going to come in last. Okay, so I go C, B, D, A by this method. All right, 2 down, 2 to go. We want extended polarity with elimination. Now, what did we do in A if that's not what we did? Oh, we have to eliminate the extended polarity. We eliminate the guy on the bottom. I think, yeah, that's what we do. So we eliminate the guy on the bottom, B. This is C. All right, so I got 10, 7, 5, 5, 4, and I've got A, D, B, C, B, C, B, C, D, C, B, A, D, D, C, D. Oh, bummer. Lost control of my marker totally. D, C, B, D, C, D, B, A. Maybe I just should have gone and got it. Okay, with elimination. All right, so now I'm confused what I'm supposed to do, as usual. And with elimination, go to count. Okay, so we eliminate the guy with the most, with the least first place votes, and that would be B. Okay, so what we're going to do, let me think about this. Okay, I'm all set. So we're going to eliminate B because he has the least.
C does.
C does. Okay, so we're going to eliminate C. And then we're going to eliminate D. And now B has 5, 7, and 4. 5, 7, and 4 is enough. So B wins. So B is in first place. All right, now we're going to write the chart again. 10, 7, 5, 5, 4, without B in it. I got A, D, A, B, A, C, D, A, C, D, D, A, C, C, A, D, C, D, A, C, D, A. I'm going to eliminate delta because he has the least first class votes and A comes in second. Okay, then I'm going to write it again. 10, 7, 5, 5, 4. Without A. C, D, D, C, C, D, C, D, C, D. When I do that, C comes in next, so D comes in last. So I got B, A, C, D is my order for that. And now I have to do an extended piecewise comparison. Okay? Sometimes I just think that they do this on purpose just to get to me, but I know for a fact that they really don't care about me at all. I'm totally irrelevant when the author made up the problem set. A, C, B, D, D, B, A, C, B, C, A, D, C, D, A, D, B, C, D, A. Okay, I'm ready. A compared to B. 10, 7, 5, 5, 4. D wins. D gets one vote. A, doesn't he?
Except B is a B.
Oh. Minor problem. A to C. Okay, I'm going to do A to C. 10, 7, A gets a vote. Okay, now I'm going to do A to D. 10, 7, 5, 5, 4, D gets a vote. Okay, now I'm going to do B to C. 10 for C, 7 over there, 5 for B, 5 for C, 4 for D. So D, B gets a vote. I'm going to do B versus D. 10, 7, 5, 5, 4. B gets a vote. And then I'm going to do C versus, well, yeah, C versus D, the last one. 10, 7, 5, 5, 4. C gets a vote. Okay, so A has 1, B has 3, B wins. Alright, so B has 1. Now I'm going to go and rewrite the chart without B. 10, 7, 5, 5, 4, no B. A, B, D. D, A, C. C, A, D. C, D, A, C, D, A. Okay. I'm going to go. Why is there a B here?
That should be a C.
Why is there a B there? I'm eliminating B. Shouldn't be any B there. Okay, so I'm going to look at A versus C. 10, 7, C wins. And then I'm going to look at A versus D. 10, 7, 5, 9, D wins. Okay, and then I'm going to look at C versus D. Oh, I don't want that color. C versus D.
When A went on the first one.
Oh, I don't know. I'll have to go back and look. A, 7, 5 for C. No, A didn't win.
Yeah, because A's above 7.
Oh, 7.
Yeah, so.
Oh, okay. So this is really an A because that 7 really goes over there. Okay. So I'm looking CD, 10, 7. And then C wins the rest. So C gets 1. Everybody has 1 vote, and it's a tie. A versus C, A versus D, C versus D. It's a tie. Okay, well, we'll allow that. So B is in first place, and A, C, D are all in second place, tied. Good. Well, that ends the requirements to continue this, and now we get to pass out the quiz so we can get out of chapter 1. Let's see. Before we do that, we should probably take attendance. Scott.
Yep.
Jacob. Okay, now, the rules say that if you're not here twice, the first 2 days of the semester, you get dropped automatically. And Jacob wasn't here yesterday either. Is it Lois? Or is it Louise? Or is it?
No, I'm Brittany.
You're Brittany? So there's a Donaldson here. Do you have a Donaldson? No. And Lori emailed me. You're Brittany, check. And you're Lene? Okay, so Lene. And we're missing Dean, or Christopher. He was standing outside that door before the start of class. All right. Listen to that. All right, so the only guy that missed both classes is Jacob. Okay, that's good. So I'm glad we did that. I imagine that if you really want to look at your book, you could. You know, like you're going to remember this stuff long enough to not be able to look at your book, you know, really give it a break, right? Would it break anybody's heart if we ended up doing our first test as a take-home test?
Nope.
All right. Just in case we don't have enough room a week from today to get it done. Always be prepared, right?
So we're having our test next week.
It would appear so, yeah, on the 14th, yeah. That's what the syllabus says. Seems like it's overly aggressive, doesn't it? Maybe I should do it with the key, pass it out with the key. Does that help any? Nah, I probably still missed something. I did that once. I did that on a physics test. Passed out with the key. The average grade was 70 something. What happened was it was a essay type test, and the key was 5 years before, and every year I changed the questions a little bit, but I never changed the key. So when I printed it with the key was wrong. Oh, the students didn't like it at all. Never did that again. Okay, we ready to start?
Not yet.
Oh, why not?
Not that fast.
Oh, okay. You're not that fast? Oh, okay. I have to think about this some. Ready now? Ready now? Okay. All right, so we got to find a last place guy. So I look up here and I say, well, it looks like C1. So we're going to get rid of C's. With C gone, B now wins because B's got more than anybody else. So we're going to get rid of B. With C gone and B gone, looks like D has won, so that means the loser is A. Any disagreement? Extended Broda count last place. Okay, so that means we have to go and assign point values 1, 2, 3, 4. A has 40, 14, 80, 80, 14, 16, 7, and 6. B has B has 60, 42, 24, 24, 14, and 2. C has 40, 56, 8, 28, 2. D has 20, 28, 32, 21, 8. Who won? $123. B1. Okay, so now we're going to get rid of B because we're trying to find out who got last place. Okay, now we're going to do it again without B. Okay, so A would have 80. No, A would not have 80. A only has 60 because that's only worth 3 now. 14. 16. 7. And 4. B1, so we don't care. C has 40. 42. 8. 21. 2. D has 10. 28. 24. 14. 8. 8. 100, 60, 70, 80, 90, 101. 40, 80, 100, more than 101. 10, 20, 30, 40, 50, 60, 70, less than that. So A is going to come in next. So we'll get rid of A. C is on top 1, 2, 3 times with the most votes. So C is going to come in next. So the loser is going to be D. Okay. If X is the winner, oh right, independent of irrelevant alternative criteria, B. So if one or more people drop out, and X should still be the winner. Round robin tournament, every player plays against each other. If 11 players are entered in a round, how many matches are played? Okay, so everybody has to play everybody else. No, that'd be way too many, I think, wouldn't it? Round robin tournament, every player plays against every other player. If 11 players are entered in a round, okay, so so A has to play everybody, right? And then B has to play everybody but A. And then C has to play everybody but D. So so A, that'd be 10. A has to play 10 times. B has to play 9 times. C has to play 8 times. And so it'd be 10, 9, 8. So it'd be 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. I don't know that that's any of that. That's 10, 20, 30, 40, 50, 5. Yeah, what's the answer?
It says, well, it says 31 players, and it's 31 times 32 divided by 2.
So there's 11 players.
Minus 1, that's 10.
So it'd be 10 times 11 divided by 2. So that'd be the echo guy. And that's what I have here, right?
Yep.
I counted 55, and that's 55. So anyway, brute force wins again. Uh-oh. Extended morality. All right, and we want to find the ranking. Okay, very good. Is A the first place winner? Yes. So A is first place. So it could be any of those. Okay, now that A is the first place winner, B would be second place. So that limits me down to only one thing, unless it's none of these. So if A and B is in fact C, the next guy in line, and the answer is yes, so that's the correct answer. All right, and with that, it's probably time to go home. So much of my idea of getting ahead or anything like that. I guess that won't work. But next week is Chapter 4, which has to do with legislator apportionment. How do you know how many representatives the state of Iowa gets? And why is it fair? Why is it more fair than some other one? Oh, it'll be such a riot. Yeah. Okay, turn in your quiz. And we'll put your name and your grade on your quiz. Several of your classmates did not put 100 on their quiz last time. Forcing you to put a grade in the grade book other than 100. So make sure you put 100 on your quiz.
Do you want me to erase it?
No, I just want you to put your name and your grade on. Well, you can mark anywhere you'd like on your quiz, you can on the back page or something. So if you put something like a 90, and that sort of forces me to put a 90 in the grade book, which isn't the exact extent of doing the quiz. Oh well. See you guys next week.
All right, see ya.
Goodbye.
How many questions is the test?
Oh, I don't know. Is it on this computer? Let me think. No, it's not on this computer, so I couldn't look. How many questions would you like?
It's not like a whole bunch, is it?
Well, it shouldn't be. Well, no, wait a minute. No. If it's a take-home test, probably 50, or 75, or 150, or somewhere around there. Now, wait a minute. If you have some number in mind that you'd like, just email me, and then I'll make it that way.
And the same kind of questions that are going to be on the quiz are going to be on the test, right?
They come from the same question bank, yes.
Okay.
And I don't make any effort to have duplicates not be there. That'd be overachieving.